Good afternoon, class. Here's exam 4 review covering chapter 4, application of differentiation, chapter 5, integral 6.1, areas between curves. Here's the second part covering 4.9, antiderivatives, 5.1, areas and distances. All right, so reminding you of various anti-differentiations that we should know the formula. For example, the power rule. When you differentiate, it results in x to the power of n becoming n x to the power of n minus 1. The reverse process, the integral is 1 over n plus 1, x to the power of n plus 1. And I justified it this way and also with differentiating the right side, resulting the left side. So the reverse process. In the case of a differentiation, you multiply by n, you subtract 1. Integration is the reverse process that way. So subtraction becomes addition, multiplication becomes division. And for example, if the derivative of e to the power of x is e to the power of x, the integral of that, integral of e to the power of x dx must be e to the power of x plus a constant. If the derivative of ln x is 1 over x, then the integral of 1 over x dx must be, by the way, 1 over x or x minus 1, x to the power of negative 1. Is ln of absolute value of x plus c. If the derivative of sine is cosine, the integral of cosine dx must be sine x plus a constant. And if the derivative of cosine is negative sine, the integral of sine x must be minus cosine x and a constant. And the rest of them follow in the same manner. And again, as far as differentiation is concerned, we are comfortable with, we can do the reverse process. Another example, the derivative of e to the power of kx is itself times k. Then the integral must be itself divided by k. So 1 over k e to the power of kx plus. So that's pretty straightforward. I hope everybody's okay with that. We're going to take it from there. So find all functions g such that g prime is 4 sine x plus 2x to the power of 5 minus square root of x over x. So what is the process? So here's the general idea. Sometimes you will need to simplify first. Factor, cancel, remove, radical notation, etc. Sometimes you will need to integrate using substitution. So in this case, 4 sine x, this one we're going to make up two fractions, and we're going to change square root of x to x to the power of 1/2. So this becomes 2x to the power of 4, and this one x to the power of 1/2. This is x to the power of 1. So this is x to the power of 1/2 minus 1 or negative 1/2. We put it in this format. Therefore, g of x is the integral of the right side dx. So we're going to differentiate term by term. We're going to integrate in the same manner, term by term. So for the first one becomes, remember, the derivative of sine is cosine. The integral is negative. Okay. So minus 4 cosine x. 2 over, so we are using the power rule, 1 over n plus 1. So we're going to add 1 to 4 becomes 5, 2 over 5x to the power of 5. Same thing here, minus 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1. There is nothing else. Now we add a constant at the end. Negative 1/2 plus 1 is positive 1/2, and this is the reciprocal of that 2. And this goes back to square root of x. So the final answer, g of x, becomes minus 4 cosine x plus 2 over 5 x to the power of 5 minus 2 square root of x plus the constant, a general solution. All right, we're going to continue looking at more examples to take care of the business. We are going again to integrate, just as we do differentiation, term by term. So having said that, 2x to the power of 4, you add 1 to 4 becomes 5. This is the power rule, everybody. And you get 2 over 5 x to the power of 5. You add 1, you get 4, so 3/4 x to the power of 4. You add 1 becomes 3 minus 7/3 x cubed. Remember, in general, we have exponent 1 when we have just x. So we add 1 becomes 2, so 1/2 x squared minus 5x and a constant, and we are done. What about x minus 5 quantity squared? It is better to raise it to the power of 2 using the fact that a minus b squared is a squared minus 2ab plus b squared. So this is x squared minus 10x plus 25. Very straightforward. 1/3 x cubed. Again, the exponent is 1 negative 10 divided by 2 minus 5x squared plus 25x and a constant. What about the exponentials? Basically, whether you differentiate or integrate, you get the same thing. The difference is, in the case of differentiation, you multiply by the coefficient of x, but in this case, we're going to divide 1 over k. So it's the answer is itself divided by 4. So 1/4 e to the power 4x plus a constant. This one we divide by negative 3. So it's itself becomes minus 1/3 e to the power minus 3x plus a constant. This one, to make sure we know what we are dealing with, I'm going to rewrite this as e to the power of half of x. So therefore, the coefficient is 1/2. And the answer is itself, but 1 over 1/2 gives you 2. So 2 e to the power of x over 2 plus a constant. That's the only reason I wrote it in this fashion, so it becomes clear that what is the coefficient, what needs to be done. That's why I wanted to do that. Pretty straightforward, everybody. What happens here? Again, the same technique as differentiation. We cut this into 3 fractions. This is x squared over x squared, just 1. Minus 7x over x squared minus 7 over x plus 2 over x squared. If we were differentiating, we would do the same thing. And of course, for differentiation, we would have changed this to 7x to the power of minus 1. We're going to change this to 2x to the power of minus 2, but we're going to write this for the sake of integration as minus 7 times 1 over x. Why? Let's go one by one. Since this is the x, 1 gives us x. Minus 7, now natural log, so minus 7, ln of absolute value of x. And 2 over x squared is 2x to the power of minus 2. We're going to use the power rule on that, meaning 2 over negative 2 plus 1, x to the power of negative 2 plus 1, which is 2 over negative 1 or minus 2, x to the power minus 1. So it's minus 2 over x and a constant. Very straightforward. What about this one? The independent variable is t because we have dt, so 1 gives you t. Cosine gives you sine t and a constant because the derivative is negative, but the integral of cosine is positive sine. What about cube root of x? First change it. So it becomes ready for the power rule. 1 over 1/3 plus 1, x to the power of 1/3 plus 1. Minus, the derivative of sine is positive sine, the integral is negative, so minus cosine, or you can say plus cosine. Either way is fine. We're going to finish this. This is 4/3. The reciprocal is 3/4. And it's 3/4. X to the power 4/3 is cube root of x to the power 4, or x. You can also write this, and this is fine, but this fine. This is also x cube root of x. That's the same thing, okay? Plus cosine x plus a constant. What about do over x dx? Let's just rewrite it so it becomes clear that this part requires a natural log. So 2 ln of absolute value of x plus a constant. What about this one? Again, rewrite it as 1/2 times 1 over x. So again, you have a natural log. This one had number 2 in front. This one has 1/2, and of course a constant. 1/2 ln of absolute value of x plus a constant is the final answer. So that's pretty straightforward, everybody. So what about the integral of x plus 1 over square root of x? Well, we're going to make up two fractions. We're going to change square root of x to x to the power of 1/2. Of course, this has the exponent 1. 1 minus 1/2 is 1/2. And this one, negative 1/2. So we have x to the power of 1/2 plus x to the power minus 1/2 dx. So far, 1, 2, 3, all of them algebraic steps. So what do we do next? Power rule. We're going to use the power rule. 1 over 1/2 plus 1, x to the power of 1/2 plus 1. This one, 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1. Since we are done, we add a constant. So this is 3/2. And of course, division by 3/2, okay, means multiplication by 2/3. 2x to the power of 3/2 plus 2x to the power of 1/2 plus a constant. You can rewrite this in the following manner. 2/3 x squared of x or square root of x cubed plus 2 square root of x plus a constant to put it in the same format, okay? That's pretty straightforward, everybody. All right, x squared plus 2 over x squared plus secant squared. So the very first thing is to work on this by making up two fractions. This one is 1. This is 2 over x squared. Now, 2 over x squared is 2x to the power minus 2. And so first and foremost, x1 simply gives us x because this is dx. The second one, we've done this before, but just let's write it here. 2 over negative 2 plus 1, x to the power of negative 2 plus 1. I hope you see it's minus 2 over x. We've done this before. Finally, secant squared. The derivative of tan x is secant squared. So the integral of secant squared is tan x. So plus tan x and a constant, and we are done. Solve the initial value problem. dp dt is 2e to the power of 3t. P of 0 equals 1. So what is an initial value problem? Any equation containing a derivative is called a differential equation, short DE. So far we've been dealing with differential equations. A function which satisfies the equation is called a solution to the differential equation. An initial value problem is a differential equation along with a specified value of the unknown function called the initial condition, meaning this is the pair 0, 1. So in other words, first ignore that and you get the general solution. And let's do that. So for now, we're going to ignore that. That means dp is the right side times dt. And if I integrate the left side, I get p of t. And I'm going to work on the right side because it's an exponential. The derivative and the integral are the same. But in this case, we're going to divide by 3. So we get 2/3 e to the power of 3t plus c. So if we didn't have this, we would be done. And this would be called general solution. Because there are infinitely many solutions here. class. This is a family of functions because we don't know the value of constant. That's okay. However, we have the pair P of 0 equals 1 means 0, comma 1 means replace the independent variable, in this case t with 0, and dependent variable y or P of t with 1. That's the meaning of it. So, of course, e to the power of, this is 3 times 0 is 0, or e to the power of 0 is 1. So 2/3 times 1 is 2/3 plus what number is 1? 1/3. Replace it. Now, the general solution with the help of one pair gives you one of those solutions called particular solution. So that's pretty straightforward, everybody. Here's another one. dy dx is 1 over x plus 1 over square root of x. When y is 5, x equals 1, that means the pair 1, comma 5. So we're going to ignore the pair, and we are going to multiply both sides by dx, and we are going to integrate both sides. So obviously, the left side is y. The right side, let's change square root of x to x to the power 1/2, bring it up, and get it ready for integration. We've done both of this. It's not a big deal, meaning both pieces. This piece is a natural log, you know that. This one, 1 over negative 1/2 plus 1 x to the power of negative 1/2 plus 1. And because we are done, we add a constant at the end. This we have done many times by now. Positive 1/2. Reciprocal of that is 2. And we get y equals ln of absolute value of x plus 2 squared of x plus a constant. This is a general solution again, because it's a family of functions. Now we have the pair 1, comma 5. We're going to replace the x with 1, y with 5. ln 1 is 0. This is 1. So we have 2 plus what number is 5? 3. Replace it, and you get one of those functions. It's a particular solution. So general solution, infinitely many solutions, a family of functions. One of those with the help of a pair is called an initial value problem, sometimes a boundary problem, and so on. So integration, anti-differentiation, fairly nice and easy. Rectilinear motion, a particle moves in a straight line and has the acceleration given by a of t equals 60 plus 4. Its initial velocity, v of 0, is negative 6 centimeters per second, and its initial displacement, s of 0, is 9 centimeters. Find its position function, s of t. So I want to remind you what we learned in, I believe, basic physics. S of t represents the position function. S prime is the velocity function. S double prime, the second derivative, is the acceleration function. Rectilinear motion, for motion in a straight line with a constant acceleration, acceleration is just a number, initial velocity v sub 0 and initial displacement s sub 0, the displacement after time t is s of t equals half of at squared plus v0t plus s sub 0. A is the acceleration. If it's due to gravitational force, becomes half of gt squared, and so on. So just to remind you what we have. So let's look at what is given. So a of t is given, and a is v prime. So V would be the antiderivative of this, which is 6 halves. That means 3t squared plus 4t and a constant. Since V of 0, now this is a family of functions, a general solution. This one will help us find the missing C. So V of 0, if I plug in 0 here, V of 0 becomes C on the one hand. On the other hand, V of 0 is -6, so C must be -6. And replace it, and we know the particular solution. Here's the velocity function. So if I integrate it again or anti-differentiated, I get to the position function S of t. So S of t, this one I hope you see 3 over 3, it's t cubed plus 2t squared minus 6t. And instead of C, I'm going to use D. Just because you can use the C or C1 and C2. I don't want you to confuse the two. Perhaps C1 and C2 would be better, but it's absolutely your choice. Just don't use the same constant here. And S of 0 is 9. And if I plug in 0, S of 0 is D. So again, if I replace the T with 0, D must be 9. Replace it, and we are done. We are saying S of t is t cubed plus 2t squared minus 6t plus 9. Again, a family of function, a general solution. With the help of the initial value, we have exactly one solution, precisely one answer. A sample of cesium-137 with an initial mass of 79 milligrams decays T years later at a rate of -1.8249 e to the power of -0.0231 T milligrams per year. Find the mass after 23 years. Understand, the rate refers to the derivative. So if this is a mass, the rate of mass, then we let m of t represent the mass. So let m of t represent the mass of cesium-137 after t years. You can use y of t or anything else that you want, as long as it's a function of t. If that is the case, then its derivative, m prime or dm dt, is this. What is this one? M of 0. Then we can find m of t in general. What do we want? M of 23. So first, dm dt is this function, and m of 0 is 79. First, we are going to find m of t, then we're going to plug in 23. So this is the process we're going to go through. So m of t is the integral of the right side times dt. Remember, when you're dealing with exponential, the derivative and integral are the same. In the case of differentiation, you multiply by this number. Now we're going to divide by this number, the coefficient of t, and the constant. So -1.8249 divided by -0.0231 and e to the power of the same thing plus a constant. You put that into a calculator, you end up with 79. So m of t 79 e to the power of -0.0231 t plus a constant. If m of 0 is 79, that means replace the t with 0 and m of t with 79, and you find the c. So this is 1. So 79 times 1 is 79, plus what number is 79? Plus 0, so c is 0. So this is m of t. So again, we have the general solution, family of functions, and we have only one of them with the help of this initial value. Now, plug in 23, put it into a calculator. And however many decimals, okay, they ask for 1 decimal. So right here, 4, next to it is 3. So about 46.4. If this is milligrams per year, per unit of time, this must be in milligrams. So it's important to put the proper units there. Okay, everybody. All right. Now let's look at 5.1, areas and distances, chapter 5, integrals, the method of exhaustion. Areas of a familiar polygons, such as triangles and rectangles, enable us to find the area of more complicated regions by filling the regions with increasingly smaller elements of known area. This is called the method of exhaustion. Take a look. You put a three-sided here. Just if you make the tree into four sides, it becomes closer to the area of a circle. Circle, the area is power squared. When they didn't know that, they do that. So we add to the number of sides, and the area becomes closer and closer to the actual area. And that one, we can cut it into pieces involving rectangles and triangles and come up with the area. So that is the method of exhaustion we use for finding the area problem under a curve. So the area problem. Find the area of the region S, here's the region S, that lies under the curve y equals f of x from a to b, x equals a to b. This means S is bounded by the graph of a continuous function f, where f of x is greater than or equal to 0. The vertical lines x equals a and b, and the x-axis or y equal to 0. Now, look at this. This is interesting. This region can be explained mathematically in the following. S represents all pairs x comma y, such that x is between a and b, y is between 0, the x-axis, and the function f of x. So this entire thing is explained here. Now, what's happening here, if you want to find the area, it's not a shape, it's not a geometric shape we are familiar with, so we can cut it into pieces. For example, if I cut this into 4 rectangle, okay, rectangular strips, the width can be anything, but let's keep it easy by making equal width. So we're going to call this delta x. And we're going to keep it the same. You don't have to, because it doesn't make any difference. It's an approximation. This is delta x, this is delta x, this is delta x. So how do you find that? In general, b minus a over n, n is the number of subintervals. If it's 4, b minus a over 4. Okay. What about the height? Well, if you look at the left endpoints, let me just do that. If I pick the left endpoints as the height, okay, so understand this is f of a. So I can do this. That's the area. Is that the area under the curve? No, that's an approximation. What if I use the left endpoints? Again, that's an approximation. So I can pick any point in between and find its height. That will be a rough estimate of the height of this rectangle, which will help us find the area of this, which is an approximation, and then add them up. So we are looking at the Riemann sum. The sum of I going from 1 to n, this is the summation notation. Remember sigma. F of x of I delta x, or f of x of 1 times delta x, all the way to the last one, f of x of n delta x. Delta x is b minus a over n. So I hope everybody's clear as to what we are saying here. Now, suppose a continuous function f is defined on the interval of a2. If the interval is divided into n subintervals, so that delta x is b minus a over n, x sub 0 is a, x sub 1 is a plus delta x, all the way to x sub n is a plus n delta x over b, then a Riemann sum. Associated with f is the sum that was mentioned before, summation of f of x sub I delta x, and that is called the Riemann sum. X sub I is any point in the sub-interval. In the previous page, I showed you we had 4 left endpoints, right endpoints, midpoints, anything makes no difference. It's an approximation. So use the geometry and procedure called Riemann sum. Partition the interval into a few. How many? Let's say 4 subintervals. Make 4 rectangles with the width delta x is b minus a over 4. And the height f of x sub 1, f of x sub 2, f of x sub 3, f of x sub. Change it and make 8 and more. And as the number of rectangles increase, the approximation gets better. So we can use the left endpoints, the right endpoints, the midpoints. These are the formulas. And I'll show you how to just avoid memorizing them and an easy way to figure them out. But just for the sake of argument, L sub n is delta x, R sub n and M sub n. This M stands for the midpoints. F of x sub 0 all the way to f of x sub n minus 1. This starts with f of x sub 1 all the way to f of x sub n. And this one is the midpoints. So the area for 4 would be from summation I from 1 to 4 of f of x sub I delta x. Now, what happens if we make n larger and larger? Becomes a better approximation. How about if we let n go to infinity? So the area under the curve is exactly the limit as n goes to infinity of I, summation of I going from 1 to n of f of x sub I delta x. Delta x is b minus a over n, and x sub I is a plus I delta x. Okay? So remember, f of x must be a continuous function. If it's positive, it represents the area under the curve. Otherwise, it represents the difference. So let's look at this example. We want to find the integral of a to b f of x dx by using summation of I going from 1 to n of f of x sub I delta x. Left endpoints, right endpoints, midpoints, and so on. And I'm not going to even look at it. I'm going to show you an easy way to see how that one works out. So how do we take care of the business here? First, when we are given this, what is the function? Well, look at this one. The function f of x is 1 over x. What is a? 1. What is b? 2. This is the lower limit 1, the upper limit 2. And what about n? They have given us n equals 5. So this is just given. So this is an easy graph. I hope you see that, 1 over x is a rational function, and we are interested from 1 to 2, locate 1 and 2. And so we want, everybody, we want this area between 1 and 2. And of course, it's not a geometric shape that we are familiar with. That's why we do the Riemann sum. So we cut this into so many pieces. How many? They said 5. So delta x is b minus a over n. 2 minus 1 over 5. So 1 over 5 or 0.2. So here's what I'm going to do. I'm going to blow up 1 to 2 and make it large so it becomes easy to see. The beginning is 1, the end is 2, and I'm going to cut it into how many pieces? 5. And that means if the first piece is 1, the last piece is 2. Let me just do it here and then I'll show you there. So I'm going to say, okay, this is 1, this is 2, and I'm going to cut this into 5 pieces, and I'm going to add how much? 0.2, and I say this is 1.2. The next one is 1.4, 1.6, 1.8, and the last one is again 2. I want to make sure we understand what's going on. In the beginning, we have A, so A equals 1. At the end, we have B, B equals 2. And over here, we add what we came up with as delta x, 1.2, 1.4, 1.6, 1.8. Now, if I want to use the left endpoints, I'm going to call it L sub 5. Why L? Left endpoints. Why 5? Because n is 5. So if I want to use the left endpoints, the width is delta x, and it's 0.2 or 1/5, and it's fixed, everybody. But what is the height? Since I'm going to use the left endpoints, I'm going to use this one for the first one, this one for the second, and so forth. So I'm going to use all of them except B, because I'm using the left endpoints. So I'm going to use delta x times f of 1, delta x times f of 1.2, f of 1.4, and so forth. So, and I'm going to factor the delta x, f of 1, f of 1.2, all the way to the last one, 1.8. So I don't use b. Why not b? Because I'm using only the left endpoints. Now, for the sake of argument, what is f of 1? We wrote f of x is 1 over x, so 1 over 1. What is f of 1.2? 1 over 1.2, and the rest of it. So I hope it's clear to everybody. I will put it into a calculator. I use a bunch of decimals. We're done. I'm going to go with the right endpoints. Y, R5. R stands for right. Y 5. N is 5. Again, I'm going to erase my work. And this time, since I'm using the right endpoints, I'm not going to use this one. I'm going to use all of this, which means delta x times f of 1.2, f of 1.4, 1.6, 1.8, f of 2, all of them except the first one. And obviously, again, 1.2 is 1 over 1.2 and so forth. And notice, by the way, before I move on, you put it into a calculator, you come up with the answer. But I want you to notice that this part is identical to this part. So if I'm doing this by hand, I keep these numbers so that I don't have to redo it again. Okay, just for the sake of it. Now, what about m sub 5? Ym midpoint, y5, n is 5. What do we do? Now let me erase my work. Now, what are the midpoints? Well, here's the first midpoint. Between 1 and 1.2 is 1.1. Then the next one at 0.2 is 1.3. 1.5. At 0.2, 1.7. 1.9. There you have it. So very straightforward. I hope everybody is okay with that. And I'm not going to memorize that, although it's easy to memorize, but just in case. Remember this line segment. You make up this line segment. It makes it very easy. So again, you're going to evaluate it in the same manner. 1 over x, so 1 over 1.1, 1 over 1.3, and the rest of them, add them up, and you come up with the answer. And normally, the midpoint is in between, and it's a better approximation by the. So that's the integral of 1 to t, 1 over 1 to 2, 1 over x dx between 1 and 2. And again, very straightforward. That represents the area under the curve when the function is positive, and the function is positive here. The velocity of a moving object is given by the function v of x is 3 times x, where x is in hours and v is in miles per hour. Use geometry to find the area under the graph, which is the distance the object has traveled. During the first 3 hours, x is between 0 and 3. Okay, so having said that, v of x is 3x, and 3, we can locate this one. Obviously, must be 3 comma 9. And we are going to use the triangular shape, half of base times the height. If this is 3, 9, that means the base is 3. By the way, they scale along the x and y. They don't have to be the same. This is 9, so half of 3 times 9, which is 27 halves, or 13.5 miles. So the area in this case, okay, represents the distance traveled. Between the third and fifth hour, well, there are 2 ways to do that. You can calculate from 0 to 5 and subtract this one from it. That's one way to do it. Or you may recognize this as a trapezoid with the area being half of h times base 1 plus base 2. So half of the height is from 5 to 3. So this is the height, everybody. which is 5 minus 3. That means 2. And then we have two bases. One of them is this, which is the same as 9. And one of them is this, which is 6 plus 9, or 15. Okay. And that's 24 miles. So just using the area, very straightforward. Use the definition to find an expression for the area of the graph. Do not evaluate. F of x is given as x squared plus the square root of 1 plus 2x, and x is between 4 and 7. All right, so find delta x is b minus a over n, b minus a over n. So first and foremost, what is a? 4. What is b? 7. What is delta x? 7 minus 4 over n. So a is 4, b is 7, delta x is b minus a over n, which means 7 minus 4, 3 over n. In general, x sub I has the formula a plus I delta x, which is a, which is 4, plus I times delta x, which is 3 over n, so 3I over n. So we write the formula. Area is the limit of R sub n, the right endpoints as n approaches infinity, limit of this summation of f of x sub I delta x as I goes from 1 to n, and n each approaching infinity. So first and foremost, what is f of x is this one. What is x sub I? This one. So let's write them. And what is f of x sub I? Well, very simply put, replace the x. So we get x squared. That means 4 plus 3i quantity squared, plus the square root of 1 plus 2 times that. And now we want the limit of this expression. The limit as n approaches infinity of summation I going from 1 to n. This expression, instead of f of x sub I, delta x times 3 over n. So this expression will times 3 over n. Okay, we'll discuss how to finish this off later on. For now, we are just evaluating. Okay. Determine a region whose area is equal to the given limit. Do not evaluate the limit. The limit as n approaches infinity of summation of I going from 1 to n, 3 over n squared of 1 plus 3i over n. So again, reminding you of these formulas that you see here. So if we write the formula, this one, a limit of r sub n approaching infinity is the summation. So the limit as n approaches infinity of I from 1 to n, f of x sub I delta x. So if we go with that, okay, we see the limit, we see this one. So this is looking like that in essence. So there seems to be 3 over n as delta x and f of x sub I as this piece. All right, so let's write these two. We know delta x is b minus a over n, and x sub I is a plus I delta x. We know that. And we also know that delta x is 3 over n. A plus I delta x seems to be 1 plus 3i over n. So we are comparing and contrasting and coming up with the answer. So if that is the case, and we know this is 3 over n, so 3 must be b minus a. And if this is a plus I delta x, then this must be what? This must be a. So If b minus a is 3 and a is 1, then b must be 4, right? So we can write y is f of x over square root of x on the interval of 1 to 4. It's not necessarily unique. We could go with the following. X sub I, delta x is 3 over n, and x sub I could be 0 plus I delta x, or 3i over n, where a is 0 and b is 3. You can go with that one. So as long as the difference is 3, in this case, 4 minus 1, in this case, 3 minus 0, then you can keep the 1 intact as part of the function. In other words, this one, y equals f of x is square root of 1 plus x. Think about it, 1 plus x, in which case from 0 to 3. So think about this. This is equivalent to y equals f of x square root of x and 1 to 4, or y equals f of x square root of 1 plus x on 0 to 3. That's fascinating, everybody. So, and again, we are going to evaluate them later. Here's the last question we're going to look at. The velocity graph of a car accelerating from rest to a speed of 120 kilometers per hour over a period of 30 seconds, over the course of 30 seconds. Okay, this is 40, 80, this is clearly 120. So I don't want to write that. This is 120. Okay. Is shown. Estimate the distance traveled during this period. Use m sub 6, the midpoint 6, to get the most precise estimate, and go with 2 decimals, round it to 2 decimals. First and foremost, that means we want this area. So we are looking for this area, okay? And this area represents the total distance covered. So first, let's go with delta x, b minus a over n. So b minus a over n, 30, okay, minus 0 over n. What is n? Well, they said m sub 6. That means n must be 6. M sub 6, n must be 6. So that means over the course of 5 seconds. Now, as far as the units, before we move on, this is 120 kilometers per hour. So we have to make this change that they have to be either both of them per second, if you make this to per second, or change the seconds to hours. 5 seconds. We know 1 hour is 3,600 seconds, 6 times 60. So delta t is 5 seconds. If I divide it by 3,600, it's in hours. So 1 over 720, that would be the change of units. Now, as I mentioned before, I'm going to draw a line segment from A to B, okay, from 0 to 30. And I'm going to cut it into delta x, in this case, delta t of 5. So we have a equals 0, b equals 30, divided by 6 is 5. So we are going to start with a equal to 0 and go 5, add 5, 10, another 5, 15, 20, 25, 30. Okay, so this is a, x sub 0. This is 30, x sub n, or more specifically, x sub 6. In other words, we cut this into 1, 2, 3, 4, 5, 6 rectangular strips. So because we want to use the midpoints, okay, if we want to go with the formula, and I really don't care for the formula too much, that means here, the very first one, if you just look at it, means this is the height. the second one, the third one, the fourth and fifth, and the sixth one. Now, if you draw a line segment, please understand this will calculate. Let me see what color I want to go with. Let's go with the red one. So this calculates the first one, the second one, and the rest of them, okay? Using the midpoints. We are using the midpoints, okay? Very simply, the midpoints. Okay, so in other words, the first one, obviously, let me just, is 2.5, right? So delta T is 5 seconds. We're going to use 1 over 720 times V of 2.5, 7.5, and the rest of it. Remember, the velocity is still in kilometers per hour. It's just the delta T that you have to be very careful. So what do you do? Let me erase my word. You actually have to read this number. This is the height. Read this number about 31.25. This one, you read this number, you read this number. You have to do the reading, and you end up with those numbers. Of course, for the exam, it will be more clear. 31.25, 66.88, 103.5, 113.75. Look at the last one. It's almost 120 because this one is very close to this. You see that? Again, you do your best of reading, and so you add them up times 1 over 720, and it's 0.725. We want 2 decimals. 2 next to it is 5, is 0.73 units kilometers, because this was kilometers per hour times hour is kilometers. That's the coverage, the distance traveled.